section 7.5, and we have now solved so many different kinds of trig equations, yet there are some other types of trig equations, and we will try to solve these. Now in the book it might say using double angle formula or half angle formula solve the following equations. So you guys have learned only the double angle formula, which is sine of 2 theta is equal to 2 times sine theta cosine theta. Okay, and the cosine of 2 theta equals, there are 3 different versions of it. First one we look at is cosine squared theta minus sine squared theta. Okay, another version is, so maybe I will write it over here. So you have cosine 2 theta is equal to cosine squared theta minus sine squared theta. Okay, so cosine 2 theta is equal to cosine squared theta minus sine squared theta, or cosine of 2 theta is equal to 2 cosine squared theta minus 1, or cosine of 2 theta equal to 1 minus 2 sine squared theta. So you should either memorize these all 3 versions, or you should at least have this with you, I mean in your mind, in your brain. So you must memorize that one, and then you should know how to get these other ones from this first version. Okay, let me put the sine 2 theta over here as well. So why are they called double angle formulas? Because basically, if you notice, we start with the twice the angle, and then in the expression we simplify it, write it as a trig function of the single angle. So these are what we call the double angle formulas. Okay, now so you don't have to worry about the half angle formula. Okay, so that is something we will come to later, but right now, what about something like this? Now note here that we have 2 times sine of 3 theta. So usually we had sine of theta or cosine of theta, and we were able to solve so many different kinds of those trig equations, but here now it is 3 theta. So how do we deal with it? Well, it's kind of, we start with the same way that we would solve a simple equation like 2 times sine of x plus 1 equal to 0. So how would you do that? Well, you can write it as sine of x equal negative 1 over 2. So now you have to get the x value. So x is going to be 7 pi over 6. And if you are looking at the primary solution, so it will be x is equal to 7 pi over 6 or 11 pi over 6. Because remember, sine is negative in the 3rd quadrant and in the 4th quadrant. Okay, so how do I do this, or how do I connect what I just did with the given equation? So I can see from here, I can write it as sine of 3 theta equals negative 1/2. So that we can say now 3 theta equals 7 pi over 6. But remember, we are looking for the general solution. So I'll say 7 pi over 6 plus 2k pi. And then also 3 theta equals 3 theta equals 11 pi over 6 plus 2k pi. Okay. So now in these problems, what you have to do now, because we have to get theta, so we have to divide everything by 3. So on both sides I divide by 3, or we can say on both sides I multiply by 1 over 3. So dividing by 3 is the same as multiplying by 1 over 3. So when I do that, on the left hand side I just get theta, and then this whole thing will be multiplied by 1 over 3, which will give me 7 pi over 18 plus 2 over 3 k pi, or 2k pi over 3. You get same thing. And from here I'll get theta equals 11 pi over 18 plus 2 over 3 k pi. So these are our general solution. This is the general solution. Hopefully this time better. Okay, so this is our general solution, and now we have to give the particular, the primary solution, all primary solutions. Now in this case, actually what happens is that the number of primary solutions increases, and by how much? If you recall, if we were doing it with sine theta, if we were doing it this way, we would have gotten only these 2 primary solutions. But now we are going to get 6 of them, because it has been 3/4 now. So how do we get them? Well, for different values of k, we get all the solutions. But now note, primary solutions live in the interval from 0 to 2 pi. So they are all positive, so no negative one. Okay. So in order to find those primary solutions, I can make a table of values. So I can say k, and in the first place I will put, actually I need more space for that, so I will write here 7 pi over 18, no sorry, yeah, plus 2 over 3 k pi, or 2 k pi over 3. And the second row I will write the other one, which is 11 pi over 18 plus 2k pi over 3. Okay, now I will take different values of k and accordingly find the corresponding values of these angles. So first let's take k is equal to 0. So this gives me 7 pi over 18, and this gives me 11 pi over 18. This is 2 angles. Now we go to 1. K is 1. When k is 1, first one is going to become 7 pi over 18 plus 2 over 3 pi. Okay. So now we take the common denominator, solve, we get, so 6 are 18, so we get 6 times 2 is 12, 12 by 7 is 19, so we get 19 pi over 18. So how do we know where to stop? Well, remember, as long as your angle is less than 2 pi, you have to include it. It will be a solution. If you get an angle more than 2 pi, then that will not be a solution. How will you know whether it is now 2 pi or not, or more than 2 pi or not? What you will do is, when you add these up, because you will notice that the denominator is throughout coming to be 18. So if you get a number, so at the bottom you have 18, but on the top if you get a number more than 35, so for example if you get 36 pi, then can you see it will be just 2 pi. But if you get 37, we are getting more. So we do not include 2 pi because we have already, the 0 is included. So now plug the k is equal to 1 in the other equation, in the other expression. So we get 11 pi over 18 plus 2 pi over 3. So I have, instead of 7, now I have 11. So do the same thing here. So common denominator is 6, 6 2s are 12. 12 plus 11 is 23. So I'm getting 23 pi over 18. Okay. What about when we take 2? So 2 will give me, the first one will become 7 pi over 18 plus 4 pi. So 7 pi over 18 plus 4 pi will give me, so 6 is the, 4 over 3 pi, because it was 2 over 3 and now k, 2 over 3 k pi, k is 2, so it becomes 4 over 3 pi. So common denominator 18, so 3 6 are 18, so 4 6 are 24, 24 plus 7, 31, right? 24 plus 7, 31. So we get 31 pi over 18. So that's what is going to come here, 31 pi over 18. And then next thing is to plug in k is equal to 2 in the other equation. So which means we have 11 pi over 18 plus 4 over 3 pi. Doing the same thing. So we have 24 pi plus 11 pi. So 24 plus 11 gives me 35. So I have 35 pi over 18. Okay. So this is actually, you can see 35 pi over 18 is very close to 36 pi over 18, which means which I showed you was 2 pi. So we are now stop here. So we have all the primary solutions here. Now note that if you, just out of curiosity, I thought I will just find out what the values of these angles are, and I found that, let me show you. So first thing, general solution, we already have the primary solutions. So theta equals 7 pi over 18. If you want, you can put them in order. 11 pi over 18, 19 pi over 18, 23 pi over 18, 31 pi over 18, and 35 pi over 18. So these are 6 of them. Okay. Looking at the next equation. Okay, I think this was supposed to be cosine squared. So if you have this situation, you can now say from here that cosine square 2 theta equal to 3 over 4. So what will be cosine 2 theta? So from here, cosine of 2 theta will be equal to plus minus square root over of 3 over 4, which gives you cosine of 2 theta is equal to plus minus square root of 3 over 2. So which gives us two equations, and then accordingly, like we did before, we will have several solutions. So what are the two equations? Well, one of the equation will be cosine of 2 theta equal to square root of 3 over 2, and the other one will be cosine of 2 theta equal to negative square root of 3 over 2. Okay, so we will solve one by one. Now remember, this will have, here we will have for 2 theta we will have two primary solutions, but because of this 2 we will actually have 4 primary solutions for one equation, and then 4 for the other equation. Okay, so looking at the first equation, cosine of 2 theta equals square root of 3 over 2. So remember, this will happen when theta is pi over 6 plus 2k pi, or theta is equal to 11 pi over 6 plus 2k pi. And now from the other equation, which is that cosine of 2 theta is equal to negative, sorry, here we have 2 theta, not theta yet. So this is for 2 theta. So cosine of 2 theta equals negative square root of 3 over 2. From here we get 2 theta equals pi over 6 plus 2k pi, and the next one will be 2 theta equal to 7 pi over 6 plus 2k pi. Why did I get these? Because remember, we are looking at a cosine, and cosine is negative in the second and the third quadrant. So we are here and here. Okay. So now this is the general solution, so I can say general solution. Not yet, is it? No, this is not the general solution yet. What is the next step to do? Next step is to divide by this 2. So to get theta. So we get, now I can say general solution. Theta equals, so I have to divide by 2, but remember that we have to divide both terms by 2. So I get pi over 12 plus k pi. Then from this one, theta equal 11 pi over 12 plus k pi. Then from the next one we get theta equals, maybe I write it over here, theta equals 5 pi over 12 plus k pi, and the last one, theta is equal to 7 pi over 12 plus k pi. So this is the general solution. Now we have to look for the particular solution. For the particular solution, now we do the same thing that we did before. So if you want, you can, make a, if you have space, make a table of values and then write down your solutions. Or if you want to show the work as well of the addition, or with the angles, so then you can show the work as well. Okay, let me make it a little smaller so that it fits. Okay, so I will now be writing the primary solution. Okay, so primary solutions. So how many will there be? Well, I told you earlier, 4 plus 4, 8. So we are taking 3. What are the k values I will take? So k, and then we have the pi over 12 plus k pi, and then the other one is 5 pi over 12 plus k pi. So k is 0, gives me pi over 12, and then here 5 pi over 12. K is equal to 1 will give me 13 pi over 12, and 17 pi over 12. What about k is equal to 2? So if I do 2, I get what? 2, 12 plus 1. 12 2s are 24. 24 plus 1, 25. So I'm getting 25 pi over 12. You can see this is more than 2 pi, because if we had a 24 pi over 12, that will be exactly 2 pi. So we discard this, check the other one, you'll get 5 pi over 12 plus 2k pi. So you get 24 plus 5, which is 29 pi over 12, which is also not. So our primary solutions are theta equals pi over 12, 5 pi over 12, then what is the next one? It will be the 13 pi over 12, and the last one 17 pi over 12. So this is how you solve with the multiple angles. Okay, we'll do the next example in next video.